Hi everyone, it's time to talk about another Leetcode problem. And today's problem is a problem from Leetcode Premium, problem 314, binary tree vertical order reversal. So let's take a look at the problem description. So we are given a binary tree, obviously with the root, and we have to return the vertical order traversal of its node values from top to bottom, column by column. So if two nodes are in the same row and column, the order should be from the left to right. Okay, so from the definition, it might be a little bit confusing. So what does it mean by column? So if you look at the example, I think it will make more sense. So this is a binary tree, right? As you can see. So this is like based on the left node's position in the left and right. It's defined, the tree can be actually broken down into columns, right? So this is column 1, then this is column 2, this is column 3, this is column 4, right? Okay, so what we have to do is we have to in the output we have to create a list of the nodes based on the columns. So the list would be something like this. So the first list will have one node 9, the second list will have 3, 15, right? The third list will have 20, and the fourth list will have 7. Okay, so this is the final output that we want to get to. So for the second example, you see again we can divide it by column, right? And then there are like 5 columns here, so there are like 5 lists. As you can see, there are 5 lists here. Okay, and another thing that is important to remember here is we have to put the nodes in the list from top to bottom. So here in this list, you see we have 3, 0, 1. So 3 first, and if they are in the same level, the left one goes before the right one. Okay, so how do we do this? It may feel a little bit challenging to understand the problem or how to identify, but first of all, we know that we have to know the number of columns, right? Number of columns, because that is the number of lists. So that one is the number of lists that we need to make, right? Okay, so how can we make the number of identify the columns? So as you can see, let's look at the third example. So this is column 0, first column, then this is the second column, then this is the third column, then this is the fourth column, and this is the fifth column, right? Okay, so let's put it like this. So if we just traverse the tree, let's think about this. If we just traverse the tree, let's say we start and we have a marker that this is we start at root, that is 0, and then we traverse the tree. It can be like we can traverse using DFS in any order, in order, pre-order, post order. And when I actually go to the left, if I just reduce the value by -1, and then this one becomes -2, right? This one becomes 1, this one becomes 2. So if I identify the columns by these values, so let's see how this is identified. So this, when you come here to the left, when you're traversing the tree, it's -1 here. And then if you go further left, you add another -1, it becomes -2. From here, when you are actually coming to the right, you see -1 plus 1, because you are coming to the right. So this one becomes 0, right? Yeah. And then from here, you go to the left. So 0 minus 1. So this one again becomes -1. Can you see that? Right. So whenever we are going to the left, we just deduct 1. And we actually keep track of that value. And whenever we go to the right, we add 1. So that way we know that how left. So we can just keep 2 values, say mean column. This one here, that is the lowest value, negative value we can get into after traversal. So that is -2, right? In this example. and max column is 2 here, right? From these mean column and max column value, we know that how many total columns we have. It's -2, -1, 0, 1, and 2. So it will be in a formula, it will be max column minus mean column plus 1, right? Which is going to be 5 here. So that means we can create a now empty list of 5 lists. Let's take a look at another example here. First thing is identifying that how many columns are there, right? So we start from 0 and then we just traverse the tree. Whenever we go to the left, we deduct 1. Whenever we go to the right, we add 1. So this one also becomes 0, 0. This one becomes 1. This one becomes 2, right? Okay. So 5 lists again. Okay, so step 1 is done. We did the tree traversal, and now we know that how many columns we need to create, right? And how many columns we have and how many lists we need to create. Okay, so let's go back to the second step. Now we have to populate this list, right? So how do we do that? And we have to populate them in top bottom fashion. So the top bottom, whenever we talk about top bottom, the first thing that comes into mind is BFS, right? Okay, so BFS, and BFS, we are using a queue. So let's say this is our queue. And what we do is we start from the top, the first row, row 0, and then we also keep track of the column because we need to know that which column this one will go, right? So initially in the queue, we'll be pushing this node 3, right? And so it will be node 3. And so this is the node and the column index is 0, right? Okay, so we put it here. And then once we take this out of the queue, we need to know that where this one goes, right? So this column 0, which index it goes into. So if you carefully look at this, so this list will represent the column -2. This list is going to represent -1. This is going to represent 0. This is going to represent column 1. This is going to represent 2. But the index is like this is index 0. This is index 1. This is 2. This is 3. This is 4. So how do we actually make a mapping between 2 and 0, right? So can we say, like, let's make a mapping. So can we say that the mapping is column, if this is the column and this is the index, so column -2 is index 0, -1 is index 1. So is it like minus mean column, right? So if I do minus mean column, let's see. So it will be column, if column is 0, the mean column value is -2. So -2, which is 2, that becomes index 2. If the column is 1, -2 plus 2 is 3, becomes 3. And 2, column 2 -2, that is +2, becomes 4. Okay, so it's easy. So you see that here the column value is 0, right? The column value is 0. So the index value is going to be 2. That means once I take this out, 3 will go here, right? Okay. Now before I take 3 out, I add another things here. So I put like 9 with column index -1, right? And then I put 8 with column index 1, right? So okay, so this time when I take this out, -1, so this was column index -1, this one goes to, so this is the column, the column -1 goes to index 1, so that means 9 goes here, so this one is gone. And then once I take this thing out, if I take this out, the column is 1, and the index is going to be 3, right? So this is going to be at 8, right? So this way I'm populating. Okay, so to summarize, the first thing I did is I did a traversal of the tree. By doing the traversal of the tree, I found the column numbers, right? Column numbers. And from there, I got the total number of columns, right? Total columns, which is actually the total number of lists, right? Okay. And that way, so I created the empty lists, right? Okay. So this was step one. In step two, I did a BFS. And after BFS, in BFS, what I did is I put the node with column value into the queue, right? So this was the queue. So I put different nodes with column values into the queue. And then I took one out and I did a conversion. So this was step three, right? The step three was column to index conversion, right? So if column was say -2, index was 0. If column was -1, index was 1, right? So the column to index conversion was column and index. So it was column value minus min column. That was the formula that we got, right? So in our case, min column value was 2. It was -2. So if the column value was say 0, it was 0 minus -2, which is index became 2. Time complexity of this algorithm. For the traversal, say we use DFS, and we know for DFS, the time complexity is order of n, if there are like n nodes in the tree, and the space complexity is order of the height of the tree, which can be, in the worst case, order of n. And then we did the BFS. So in BFS, the time complexity is order of n again. For n nodes, it will go into the queue n times and brought out of the queue n times. And the space complexity is the space for the queue, right? So we have this queue, and the queue actually takes, in the worst case, all n nodes can be added to the queue altogether. So in total, the time complexity is going to be order of n plus order of n is order of n time complexity. And the space complexity is also going to be order of n. Okay, so this is the code. So this is the helper function. We can also call the DFS function for traversing the tree. You see that it takes the tree node and also keeps track of the column value. If the node is null, then we return. Otherwise, we know what column we are in, and based on that, we see if we update the value of min column and max column, and then we call it recursively for the left node, reduce the column value by 1, and call it again for the right node and increase the column value by 1. Okay, so that's what we do here. We start with the root and column value 0, and meanwhile we update the min column value and max column value. Okay, so next we have the min column value and the max column value. So we know that what is the length of the result list. So we create a result list and add that many lists into that parent list, right? Okay, so if it was -2 and 2, there will be 5 lists added to this parent list. Then we do the BFS here. So we have a queue. And the queue it's a queue of pairs. The reason is we still have to keep track of the column value, right? To get the index of the list, which list the node goes into. First, we add the root with column value 0, and then this is a BFS. Until the queue is empty, we extract one pair. So we get the column value, we get the node value, and then from the column value, you say we get the index from here and add to the corresponding list. We add the value of the node to the corresponding list. Okay, and then we just, if the left of the extracted node is not null, we add it to the queue again, as we do the same thing for the right. So you see, this is the BFS part. And finally, all the lists are populated and we return it. Okay, so it looked a little bit tricky, but I hope you understood the concept. We'll come back with another problem, and thanks everyone for watching.